This lesson is on inscribed angles and central angles. The main idea is, remember that a central angle goes from the center without its vertex. So it goes from a side to the center to the side. So the vertex has to be on the center to make it a central angle. When we had central angles, the central angle had the same measure as its arc that went with it. Now, if you'll notice, we're looking at some inscribed angles. Inscribed angles means that our edges are going to be on the actual circle itself as well as our vertex. So there's some properties that are involved. For example, if you look at this right in here, you'll notice that we have a quadrilateral. One of the properties involved with a quadrilateral is that the opposite angles are going to be supplementary. And it's really important that you understand that this is not holding the same concepts as the parallelogram in which the opposite angles were congruent. If it is a quadrilateral that has all of its vertices on the circle, then the opposite angles are going to be supplementary. So that means that this angle, whatever it is, plus the 105-degree angle is going to be supplementary. It's going to equal 180. So if we solve for that, we would be able to quickly find out that that angle is going to be 75 degrees. If you look at number 2, here's an example of that inscribed angle. With the inscribed angle right here, its vertex is on the side. So the relationship between our inscribed angle is that this angle will be half of the measure of the arc that its vertices or its endpoints are on. So if you'll notice here, our endpoints Q and R are right here, and that's our arc measure is 178. To find that this inscribed angle measure is, you're going to do 1/2 of 178 degrees. When you do that, you'll find that it's actually 89 degrees for this inscribed angle. So what gets a little bit more confusing is when you start to look at problems like number 3 here, because there's a lot more involved with these shapes. But look, here our vertex is on the circle, as are the endpoints here. So if you're asked specifically to find this arc goes with the endpoints here of this inscribed angle. So this inscribed angle is 41 degrees, and remember, this is going to be half, so half, whatever the arc size is, so we'll call that x, is going to equal the measure of our inscribed angle. So if we multiply both sides by 2, we're going to get that that arc length is actually going to be 82 degrees. Another example right here. Again, you have the inscribed angle. And so this arc that goes from R to S is going to be 2 times this amount. So we would have 85 degrees times 2 to give us a total of 170 degrees for this arc that the endpoints of our inscribed angle are touching. So when you go through these problems, look for the relationships among these different arcs, because sometimes they're going to get a little bit more complicated. I'm going to show you, like question number 6, how it starts to get a little bit more complex. You're asked to find this, and there are multiple ways that you can do this. I'm just showing you one. If I look and I say, okay, I've got 104 degrees here, that means that this large arc from X, W, V is going to be 2 times this, so 208 degrees for this whole thing. Well, if this whole arc here is 208 degrees, and I already have 108 of it here, what's left? Well, this part right here would then be 100 degrees right here, because 100 degrees plus 108 degrees gives me a total of 208 degrees to match this being doubled. Now, we're also going to look at another piece of information. If you look at this inscribed angle here, this is 81 degrees. That means this entire arc right here is going to be double that. What's 81 times 2? Well, this whole thing here is going to be 162 degrees. But look, we've already used 100 of that. So if this whole thing here is 162 minus this 100, it leaves me with 62 degrees for this minor arc. And this minor arc CV is what we've been asked to find for our measure. So a lot of these problems involve doing some problem solving. You're going to be looking at the inscribed angle, see if you can get an arc measure on the outside. Remember, the arcs going all the way around will be 360 degrees.